Hi, welcome back to the breadboard. As you know, I've been running a project over the last year or two related to motion control and building CNCs, sharing my experiences with you as I go. One of the things I haven't had the pleasure to play with yet is a proper spindle for the CNC. I've used a woodworking router in place of a purpose-designed spindle. So I've been on the lookout for one for quite a while, and some other accessories to use with the CNC to build other projects with. Banggood recently approached me and asked if they could help out with some of my projects. In return, just provide links to people for the parts that I use and to give a fair assessment of any components that I may have selected for use with the project. So they've kindly sent me a spindle, 400 watt, 48 volt spindle. They've sent me a encoder wheel, which I can use to build a handheld pendant or something like that. Some laser goggles, because I've recently got a laser into the home that my daughter uses, and also a blue laser, which I showed you in a previous episode. So without further ado, let's just get close to the bench and have a look at these. We'll also power them up on the bench and give them a quick run before we install them onto the CNC. I will actually do the CNC demo in a separate video. I have to design and 3D print a bracket for the spindle because the one that comes with it is designed for mounting onto a different size plate. And I have an 80/40C extrusion as my Z-axis, or a 60/20. I'm just looking across to my smaller one. And the pitch of the mounting brackets don't fit for that. That doesn't mean it's no good. The mounting bracket comes with the spindle. It just means that it won't fit to what I have. So I'll either make a bracket to adapt it to it, or I'll just simply 3D print a new holder for it that will fit perfectly onto the spindle in the same way as I did for my Bosch Colt router that I have it on it right now. So anyway, let's go have a look. Okay, so the one thing I forgot to mention that Banggood were also kind enough to send me was a zero set tool. So what you can do with this is on the CNC is you place this on your work surface. It is a known height. You can measure it with a caliper, and you clip this onto your input of your CNC controller. Put this on the bed, and the other wire you clip onto the bit that you're using, and then when you zero adjust, as soon as it touches the metal, it makes a contact, and then the CNC controller will know that it's hit the exact 0 point, and you can then offset the height of the little puck here from the 0 to get a proper reading, and it makes it a lot easier. Now there are more sophisticated ones on the market, but this is an inexpensive, easy to implement solution, and I will be showing you in a future video how we wire this up into a Mark III motion controller and also into an Arduino type base controller. So anyway, let's get round to all of the different things that I have here. First one is the spindle over here. This is a 12,000 RPM maximum spindle. It is a brushless, so it basically is a three-phase motor. We have a controller with it. This one is 48 volts, sorry, I said 400 watts. It's 500 watts and 12,000 RPM. We will hook this up on the bench. I have a power supply over here ready to try it, and it has, I think it's an ER11 collet. Yes, it's an ER11 collet with a, looks like an 1/8 inch adapter in. Now it doesn't come with any additional inserts, but you can buy them quite inexpensively from Banggood or other places. The spindle has an air fan at the top for air cooling. Yeah, as I said, it is brushless, so there's no fittings on the side to replace the brushes. It weighs what feels like about a kilo or a couple of kilograms, so quite a mass. If you're putting, it's probably a bit too heavy to put on something like a hybrid 3D printer that can also do CNC work and things. It would probably be way too heavy for that unless you had some big motors on it, but certainly good enough for powerful enough and light enough for the CNCs that I've built that I've shown you in other videos. The controller that comes with it, well, actually is this nice little unit here. It's got heatsink built into it, connections for the power supply UVW, which are the 3 phases of the controller, the wires of the motor already have the connections on them to plug right into here. It has and it comes with a potentiometer so that you can manually set the speed. That's already pre-wired into an adapter that just plugs right into the front. And then you have a start-stop switch and a small piece of wire just so that you could set up your initial power connection. I will be changing this obviously to something a bit more substantial when I wire it into the CNC itself, because I don't want to be dropping too much current across these wires, and it's also not very long. The other thing that the controller supports too, though, is a 0 to 10 volt from a controller. So right now we're just using 0 to 10 volts with a potentiometer on here to set the speed, but you can use a 0 to 10 volt input as long as it's ground referenced from things like a Mach 3 motion controller, which will allow you to have full control from, say, the Mach 3 software or universal CNC. Basically, it'll respond to G-code commands to set the spindle speed. There is no feedback in this controller, so it is a fairly open loop speed, so you know that it's sort of maximum 12,000 RPM, minimum 0, but where you are in the middle of that will depend on what the load is you've got on it and things like that, and whether you're running on a 48 volt supply or a 24 volt supply, etc. The mounting bracket that comes with it is quite substantial, aluminum bracket. The screws that are here look like they're M8, I think. Yeah, about M8 or no, bigger than M6, that's for sure. So long enough there's the bracket, so you would mount that onto your Z plate, and you would bolt right through the bottom bracket into the plate. Now, as I said, this is more than 80 millimeters across, so it won't fit on my Z-axis. So I'm going to do a 3D printed version with the correct pitch, and I already have one that I've just sort of brutally adapted from a previous design that I had. I adjusted the hole size to 55 millimeters, which is what the shaft has on here, but there is a lip on the top and bottom, and there's not enough flex in this to be able to get the spindle through it and then mounted. So what I did was I chopped off the edges to make it flush, just to see if that would work. Either way, this was either a wasted print or something I could adapt. So I had done a 60% infill with thick walls, so it will easily support me doing this. Once I've confirmed that this will be firm enough, then I will complete the design with a different clamp for the top and reprint it, and I'll show you how I did that in a separate video as well. But the idea is that you've got 8 mounting holes on the back here set at the 20 millimeter pitch for the 80/40 extrusion, so we can just screw that straight on and it will provide us a nice rigid mount for this. Now, the one I've done before for the Bosch Colt router works very, very well and is very, very rigid once you've screwed it down. So I don't see why this wouldn't be as rigid as the one I use for the Bosch Colt, especially seeing as the sides are thicker. So that completes the run through on the spindle that came. The next thing related to the CNC, and I will do a follow-up video right away with this, is a encoder wheel. Now, you've seen lots of small encoders that are basically the size of a potentiometer, where you have just a little knob and you've got to provide power and everything else. What this one has is it's actually powered, and you provide it with, I think, 5 volts and 0 volts. I think my one downside negative that I would have to say about this is that all of the instructions are in Chinese, and there are a few pointers that will indicate what it will work with. For instance, there is +5 to +12 volts indicated here, so definitely not going to run on 24 or 48 volts, so be aware of that. It's got a less than 100 milliamps power consumption. It's got, let's see if it tells me here, it has a signal A and B output, but it also has the inverse. So it has an AB and a not AB. So depending on the way your controller works, you could use either of these. And that's pretty much it. It's actually quite a substantial weight and has a very nice click feel to it. So I look forward to actually getting this integrated into a nice pendant that we're going to design, and I'll share that process with you, and then get it hooked into Mach 3 and other things, maybe via Modbus or something like that, or serial, at least serial communications anyway, so that we can control the CNC just from a little hand controller. So anyway, this is, I'll put the price up here. And I'll provide all the links to this to the Banggood website. But for what you get, it's not very expensive, and it gives you a nice, very professional wheel. A lot of the smaller, if you just get the little PCB type encoders, they're not really designed for this kind of process. They don't have as good a click mechanism. They're not as fine and indented, and overall they're not as robust. You'd have a much smaller knob on it. This one is very substantial. It feels very solid, and I think it's about the right size for when you're doing something like a CNC control pendant anyway. So that is the incremental encoder. The other items that Banggood has kindly sent me, and this relates to the 2 laser projects. They had actually sent me in a previous mail a blue LED laser here, which we're going to add to one of the CNCs. And what this needs, of course, is safety glasses. So when you're running any laser, you should be wearing safety glasses. The reason I haven't done this project yet is because I didn't have any safety glasses that would cover this range. Even with the CO2 laser that my daughter uses, we didn't have safety glasses right away for it. So when Banggood was asking me what other things I would like to have a look at, they weren't suggesting things to me and then just saying please review it. They asked me what I would like to see, and I suggested that they send me a couple of pairs of glasses, one for the blue LED laser and one for the CO2 lasers. So what we have here are, these are the first ones. These are inexpensive. Again, I'll put the price up on Banggood. It's going to fluctuate depending on your region and exchange rates and stuff like that. This one is a wide range pair of glasses. It will cover right from the blue laser right up to the CO2. Now, as you can see, it's quite dark here, but the one nice thing about these is that it will go over, if you're a glasses wearer, it'll actually sit over your existing glasses. We'll try these on in a moment. Actually, we do that now. Why not? So here we go, a real close-up with the full range one. So as you can see, I'm wearing my glasses, and it will clip right over there. I've got a little bit of reflection because I've got lights directly above me, but they will go over my regular reading glasses and provide a bit of additional protection. So that's the general range, and these are, as I said, quite inexpensive. They do not, that I can see, have a certification written on them. So looking at the glasses, I can't see anything stamped on the lenses. So for a industrial kind of sense, these probably would not be allowed to be used. There is on the side here, there is an ANSI Z87.1. I'll have to look up what that actually means. And on the other side it says Protec. But that's on the arms. I don't know whether that relates to the actual lenses, but we will see. The nice thing is they're also on the side. The other benefit of these, of course, is they do provide you some protection. Now they feel like they're made out of some kind of acrylic. So even with the CO2 laser, that will provide a protection against a divergent beam. If you have a direct beam that is focused, it will melt through this in a matter of a fraction of a second. But you would have to be within a couple of millimeters of the focusing lens, or within an inch of it, and be looking into the beam or having a very close reflection. And the chances of that happening are very, very slim unless you do it deliberately, of course. So that, anyway, that's the mixed nanometer range pair of glasses. The other one I've got is for CO2 only, and that is this pair. And these are designed for somebody that doesn't wear glasses. They're a neutral optically, but they don't have room, you know, if you're wearing your own glasses inside. So I would have to put contacts in or something like that if I was going to be wearing these. They seem to have a coating on, but I can't find much information that describes anything. And these ones don't have any codes on it at all that I can see that would indicate the safety standards or anything like that. The website does claim that they have the CO2 at the 100, anyway, CO2 laser frequencies for the wavelength. So I will see if I can set up a test. I don't want to put a laser beam right through the middle, because no matter what, with CO2 lasers, they will provide you protection. Even acrylic safety glasses, pretty much any optically clear to the naked eye, will provide protection against infrared lasers at the high bandwidth, because the plastic becomes totally opaque to it. So it will absorb the radiation, and as a divergent beam, it won't be enough energy to melt through it and get to your eyeballs. Obviously, again, if it's focused, it will go through fairly quickly, but the chances of that, like I said, are pretty slim. Now, the other nice thing with these is they come with a pretty substantial, both pairs come with a fairly substantial case to keep them protected when you're not wearing them, and a cleaning cloth. Now, obviously, the cleaning cloth is an inexpensive thing, but it's nice that they've included it. And I also like the fact that these cases have like a little carabiner clip, so you can hang them somewhere close to the laser or somewhere else where they're not going to get covered in dust and everything else. So that is the two pairs of glasses. Now, my daughter's going to use these ones because I have to wear glasses all the time. I do not have close focus without glasses on, and I don't really like the idea of wearing contact lenses when I'm near a laser, because they would melt very, very quickly if the laser beam hit them, and probably, you know, adhere to my eyeball, and that would not be nice. So I'd rather have something that was further away that would provide a little bit of protection before the laser actually gets to my eyeball. Anyway, so that's the two pairs of glasses. We've covered, I think, everything else here. So I think the next thing to do is to power up my power supply here and give a couple of these things a little bit of a play. So let's do that. Okay, first thing up is the 500 watt 48 volt spindle. Now, of course, 500 watts at 48 volts is going to be pretty close to 10 amps. So what I have here is my RS Components 48 volt 10 amp power supply. This is actually a Meanwell power supply that RS sells as the RS Pro line. So the reason I'm using this one is because, one, I don't have another 48 volt power supply to use, but secondly, I want something that I know is going to be reliable and give me a good 48 volts out. It's not a cheap power supply, but when you're building a CNC and you want to be able to rely on it, especially if you're doing it as a business, you do want to consider buying reputable parts from reputable sources so that they're going to give you a good amount of reliability. Nothing worse than buying some power supplies for a project. You go to put them in and some of them don't work right out of the gate. And I have had that experience from some of my friends that have shared it with me, and I have had power supplies of my own that I've bought from low cost sources, let's say, that have not worked right off the bat. Now, the service is usually quite good, but when it takes you 2 months to get a replacement, that's a long time if you are in an industrial environment and trying to make money with it. If it's just a hobby and you don't mind waiting, then that's great. But I have these ones for the projects that matter to me, where I want to make sure that it's very safe and very reliable. The spindles, I've never used this kind of spindle before, just to clarify. I've only used routers, woodworking routers on my CNC machine, and those are all 110 volt standard kind of things that you would get from your hardware store, like B&Q in the UK or Home Depot in Canada or something like that. So anyway, controller, 48 volt power. Verify the switch is set to off right now, not on, although it depends on how they wired this, of course, because in Canada the O is often, well, anyway, it could be a lot of confusion between an O and a 1. It's on the right hand side, so I'm assuming that, well, let's see, I guess. See, it's on the O, so that theoretically would be off, but it doesn't look like it's wired that way. We'll see. I've got the speed control set to what looks like minimum. Is connected to 0 volts to the center wiper. So hopefully none of this will go poof. I have the mains set to a quick connect block with just a simple 5 amp fuse. I don't anticipate this to take a whole bunch of power because there is no load on it. This is actually one that I got from RS Components as well, and I've adapted the plug for 110 volts. The neon indicator works perfectly well with 110, and when you lift the lid it disconnects both the live and the neutral for ultimate safety in the wiring. All right, so these are very handy when you're doing on the bench testing and things like that. All right, let's power this up. Hopefully it won't start spinning, so let's just keep a hold of this just in case. All right, so the power is on and we've got an alarm, and that's probably because this is the enable on here is probably turned off. So if we turn this to on, that makes no difference at all. I guess the alarm is, if the flashing seems to indicate that it's at 0 speed. As you can see, it's flashing now that I've turned it down. So let's see how noisy this is. I know that the woodworking router is very noisy, so we'll spin this up first. That's at low speed. Don't have a tachometer, so I can't check right now what the speed actually is. Maybe that's something we can do a little project in a separate video, maybe use an Arduino or something to make a tachometer. I need to stop it vibrating away. So that's at full speed with 48 volts. That's not very noisy. I know it sounds it, but it's not. Or it might sound it to you. I'll grab my woodworking router in a second and let you hear that as well, just for a comparison. So I know you can't see it, but this is a standard Bosch Colt router. I'm standing as close to it as I was to the CNC spindle that you're currently looking at. So I'm going to turn it on at its lowest speed, and because I'm using the same microphone on my lapel, you should get a similar volume. Well, louder because it's this one, but anyway, let's do this. So that's on its minimal speed. Let's just crank it up. And just to recompare back with this spindle again, way quieter. If I lift it up off the bench so it's not vibrating through the bench, that is much quieter. So far so good. The next thing is to get the bracket printed up and get it onto the CNC machine, so we can actually give it a test cutting things like aluminum, because that's one of the things I want to be able to do with this, is to cut aluminum so that I can make some brackets again for my bigger CNC, because I stole some when I built the smaller one. Anyway, next thing to have a look at is this pulse converter, the encoder wheel. So give me a few minutes. Well, for me it's going to be maybe 10 or 15 minutes while I quickly wire up a bit of a circuit, but then we'll try this. I'll need to use a different power supply, of course, because this won't go above 12 volts, but I'm going to run it on 5 just to be safe. So back in a moment for you almost immediately. Okay, I've wired up the encoder with +5 volts, 0 volts, and just attached 2 wires so that I can easily connect my oscilloscope to the outputs. And what I have, and I'm going to put a screen capture up from this anyway, but I have my MDO 3054 tracking the signal. So here we go. Let me just reset for a single capture, and there we go. And as you can see, you've got 2 channels. It's just now that I've captured that, we can increase the view of it. Just move that across a little bit. There we go. So we can now zoom in on an area just to see what this looks like. And you can see here, ignoring this first little bit that was not part of the capture, we have these overlapping waveforms. You've got 2 low, 1 high, second one high, first one low, back high again, second one high, low. So it's following a pattern. Now if I try and slow this down with a capture, I think. Okay, I've set up a slower trace, adjusted things. Hopefully I'll be able to get a better image from this, so let's give it a go. And hit stop. Now we should be able to zoom in on what we had here. I set it to a 1 meg and simple mode capture. So we can see here that the yellow trace is leading the blue trace, which would indicate a clockwise, in this situation, motion. And there is an overlap as well. So you got high, both high, yellow low, then blue low, then yellow high, yellow low, blue low. All right, it's a repeating pattern in the direction. Now if we scroll across, sorry, stay there a second, and go to the other side. So this is the point where I'm changing direction. So, sorry, what we saw here was the yellow leading the blue after both were down. What we should see after this is blue leading the yellow after both are down, to indicate that it's reverse direction. And here we are, and as you can see, we have now the blue leading the yellow. Now I'll put some better pictures up so you can see this, but this is basically how an encoder works. And the signals we've got here, I'm supplying this with 5 volts. It looks like it's 500 millivolts, so the output is only going up to a couple of volts, not sure why. Okay, just a quick bit of feedback. I made a slight mistake there. I mentioned that the volts seemed to be low on the oscilloscope, and they were. But the reason was I thought I'd set 5 volts output on my power supply, but it was still set to 3.3 volts. So as you can see here, now that I've set it to the proper 5 volts, I am actually getting a full, or a much stronger output signal. So these are 500 millivolts per division. It is with a slight offset. So we've got, so as you can see here, 0 volts, and we're almost at a full 5 volts. We've got 1, 2, 3, 4, 5, 6, 7, 8 divisions at half. That will be 4 volts. So it's just under 4 volts that are coming out, more than enough for detection by 5 volt logic. And obviously if you're going to drive it into something like a Raspberry Pi or whatever, or 3.3 volt logic, you could always reduce the input volts. It seems to work fine on 3.3 volts, even though it says between 5 and 12. So that's cool. Anyway, just thought to let you know that, just so we had it complete. See you next time. Bye.